This is the second part video in graphing polynomials. In this video, we are going to look at some examples. First one, we want to graph this cubic polynomial. So to graph this polynomial, we want to think about the end behavior, figure out the x and y intercepts. End behavior is decided by looking at the leading term. So it depends on the degree of the polynomial as well as sign of leading coefficient. So in this case, end behavior for this polynomial is going to be, we have an odd degree with the positive leading coefficient. So that's how my graph is going to look like. Let's go ahead and find the x-intercepts. To find the x-intercepts, we make the y 0, which is same as p of x cubed minus x squared minus 6x. Let's factor it. And the factors will be x minus 3, x plus 2. So 3 zeros are 0, 3, and negative 2. So I'm going to mark 3 x-intercepts. This is negative 2, 0, and 3. And let's find the y-intercept now. Y-intercept. To find the y-intercept, we make the x 0. So if I plug the x 0, the right-hand side becomes 0. So plug the x as 0 in the original polynomial that is given to us. So I can see now y-intercept is going to be 0. So graph is going to touch the y-axis at y equals 0, which is at the origin. Right. We know the end behavior. We found the x-intercepts. We found the y-intercepts. Let's go ahead and think about pick some test values and figure out how high or low I need to go in those regions or zones, because I already know that my graph is going to be going up like this and going down like this by using the end behavior, and multiplicity of each of the root is 1. Each of the zeros is the 0 only once, so that means my graph is going to cut through at that point. So I'm going to cut through at each of these points. So let's figure out when x is negative 1, what's happening. What's the y value when x is negative 1? And what's the y value when x is 1 and 2? Let's go ahead and plug them into the original equation and see what we get for the y values. When x is 1, we'll have 1 minus 1, which is 0, negative 6. When x is negative 1, so plug it in, negative 1 minus 1 plus 6. That would be 4. When x is 2, 8 minus 4 minus 12. Negative 8. All right, so I'm just going to mark these points to kind of give me estimate. When x is negative 1, y is 4. So I'm going to mark these points by estimate. I'm going to be approximately here. When x is 1, y is negative 6. About here. When x is 2, y is negative 8. And I'm just going to connect these dots. Again, it's a sketch of the graph. It's not exact graph. So graph is going to be smooth, continuous curve, no sharp corners, no holes in the graph. And that's the graph of this cubic polynomial. Let's see another example. This one, we have negative 2x to the 4th minus x to the 3rd plus 3x squared. So let's go ahead and figure out the end behavior first of all. The end behavior of the graph, it's a even degree and negative leading coefficient. That means my graph is going to be, end behavior is going to be, it's going to go down in both far left and far right directions. Let's think about x-intercepts. To find x-intercepts, we make the y 0. So 0 equals negative 2x to the 4th minus x to the 3rd plus 3x squared. Factor x, negative x squared, 2x squared minus x plus it would be plus x. Be, because we pull the negative out, would be right here, 2x squared plus x minus 3. Let's go ahead and factor negative x squared. We can divide both sides with negative 1 if that helps. We're going to be doing bottoms up method for factoring here. Two numbers that multiply to give me negative 6 and add up to give me 1 are 3 and negative 2. We're going to divide them both with a 2x and 2x. So we can cancel these factors. So x minus 1 is one factor. 2x plus 3 is another factor. Now, x-intercepts, roots, zero solutions are the points where each of these factors will become 0. X squared becomes 0 at x equals 0. X minus 1 becomes 0 at x equals 1. 2x plus 3 becomes 0 at x equals negative 3 halves. We can plug each of these equal to 0 and solve for x to find these. So I'm going to mark my x-intercepts, x equals 0, x equals 1, and negative 3 halves. Now to find the y-intercept, we will make the x as 0. So if I plug x as 0, the y-intercept is going to be equal to 0. We already know the end behavior for this graph. So let's go ahead and figure out in between some test values, pick some test values and see what's happening in between. So which test values I should pick? I'm going to pick x as negative 1 here and 0.5 here. Negative 1 and 0.5. So when x is negative 1, what does y come out to be? Let's see, negative 2 plus 1 plus 3. 4 minus 2, y is going to be 2 when x is negative 1. So about here. And when x is half, if I plug as x as half, see what does y come out to be? Plug it into the calculator. Be 0.53. Y would be also about half. 0.5 when x is 0.5. So my graph is going to look the multiplicity of root 0 is 2. Be extra careful. So your graph is not going to cut through at the point 0. It's going to cut through at point 1 and negative 3 halves. But at point 0, it's going to touch and bounce back. That's how my graph is going to look like. Again, it's really an estimate and it's not the exact shape because I should pick more points to know the exact shape, but that's just a sketch of the graph. Another example, graphing the polynomial function using its zeros. So for this function, I'm going to see it's already factored. I'm going to think about the end behavior. It's not a fourth degree polynomial because when you distribute, there's x to the third degree here, and there's x to the second degree, x to the fourth degree. So altogether, it is 4 plus 3, 7 plus 2, 9. It's x to the 9th degree polynomial. So the degree here is x to the 9th, and leading coefficient, if I multiply all these, it's going to be positive. Leading coefficient is going to be positive. It's a 9th degree polynomial. So my end behavior is going to be like this. Now, good thing this polynomial is already factored. The factors are, or zeros, maybe I should call them zeros because we already have the factors. Zeros for this polynomial are going to be x equal to 0. And let's think about multiplicity as well. That way we can have a better idea about shape of the graph. X equals 0. What's the multiplicity of that 0? That 0 occurs as a 0 4 times. 2 occurs as a 0 3 times. And negative 1 occurs as a 0 twice. So that means at negative 1, the graph is going to bounce back because if a 0 has a even multiplicity, graph does not cross the x-axis at that point. It bounces back. At 2, it's going to cross and it's going to be a little flat because the multiplicity is greater than 1. At x equals 0, again, the multiplicity is even. It's going to bounce back, but it's going to be flat. It's going to bounce back and flat. All right. I have some idea now. X equals 0, x equals 2, x equals -1. And I can think about what is happening at -1/2. So if I want to make a table to be a little more, to figure out more points to find the test values, I need to find out what's happening at -1/2 and what is happening when x is 1. When x is 1, I'm going to plug them into the original equation now. So when x is 1, what is y going to equal? It would be p of x equals 1 times 1 minus 2 is -2 to the 1 minus 2 is -1 to the third power. 1 plus 1 is 2 to the second power. Y would be -4 when x is 1. When x is 1, y would be a -4. So I'm just going to mark it about here. And when x is -1/2, let's see what happens. When x is -0.5, -0.5 to the fourth power, -0.5, -2, -2.5 to the third power, -1/2 would make it 0.5 to the second power. Let's figure out, that would be, negative is going to disappear, 0.5 to the sixth power, -2.5 to the third power. Turns out to be -0.24, -0.24. So I have some idea the y is going to be still negative over here. All right, so let's go ahead and graph this. I know my graph is going to touch and bounce back at 0, and my graph is also going to touch and bounce back at -1. So bouncing back at 0, bouncing back at -1, crossing at x equals 2. That's how the sketch of the graph looks like. Right, another example, graph the polynomial x to the fourth minus x to the third minus 2x squared. It's a fourth degree polynomial. So first thing I'm going to think about is the end behavior. End behavior for this polynomial is going to be, it's an even degree with the positive leading coefficient, which is 1. So the end behavior will look like this. End behavior of a graph is only determined by the leading coefficient and the highest degree in the polynomial. Next, let's figure out the x-intercepts. To find the x-intercepts, we make the y equal to 0. 0 equals x to the fourth minus x to the third minus 2x squared. So it turns out to be x squared. Square. I can pull out an x squared minus x minus 2. Now let's go ahead and factor it out. Two numbers that multiply to give me -2, add up to give me -1 are x minus 2, x plus 1. Now the zeros here are going to be x equals 0, which is twice. Multiplicity is 2. And then we have x equals 2, multiplicity is 1, x equals -1, multiplicity is 1. That means the graph is going to cross at these 2 points at x-axis, and at 0, it's going to bounce back. Okay, let's go ahead and graph it. So at x equals 0, it's going to touch and bounce back at x equals 2, and then x equals 1. and we already know the end behavior. So it might be helpful to think about a few more points in here to see what's happening at, this is -1. So I'm going to make a table of the values at x equals -half, what is happening, and at x equals 1, what is happening, just to get a little estimate how high or low I need to go. When x is 1, that should be easier to plug in. Let's see. The y turns out to be, when x is 1, okay, -2. When x is 1, y is going to be -2. And when x is -half, let's see, what does y turn out to be? -0.3. -0.3 is the y. All right, so I think we have some idea how my graph is going to look like when x is 1, y is -2, x is -half, y is still negative. And my graph is gonna touch and bounce back at x equals 0. So at x equals 0, it's gonna touch and bounce back, and it's gonna cross at other 2 points, right? So we are ready to sketch the graph of the function. And that's the sketch of this polynomial graph. Again, your highs, relative max and mins might not be exactly shown in the graph because it's really just a sketch of the graph. And we could pick more test points to be more accurate in between my x-intercepts if I wanted to get accurately figure out the max and mins. Next, we're going to talk about intermediate value theorem. Intermediate value theorem says if f is a polynomial function with real coefficients, f of a and f of b have opposite signs, then there's at least one value of c between a and b for which f of c is equal to 0. Basically, it means, for example, I have this polynomial x to the third minus 2x minus 5. It's not factorable, so we cannot figure out the factors by factoring techniques. We cannot figure out the x-intercepts. But if I just start randomly plugging numbers for x, and I see two different x values give me a positive and a negative y value, that means my graph is crossing the x-axis in between those 2 points. For example, if I plug f of 2 here, if I plug x as 2, my y value is -1. And if I plug x as 3, y value is 16. So I can see that the graph is going to cross the x-axis in between those 2 points. So there is a 0 between these 2 points. And we can start cutting the interval in half and figure out the 0 to the nearest 10th. If we want, it takes some effort, but it's possible to find the 0 by cutting the intervals in half and applying the same, checking the signs of the endpoints and narrowing our interval down to the exact 0. That was all for this video.